So we've got metals versus non-metals today, and then also dot diagrams, which we'll talk about most. The periodic table is set up so that all of the metals, the elements that are metal, are on the left. Oops. And then non-metals are on the right. But they kind of do this stair-step division to separate them. Metals tend to lose electrons. And then non-metals usually gain them. Looking at this separation, so like if non-metals are over here, and the metals are to this side, and knowing what we talked about yesterday, and the day before that, why do you think these non-metals are more likely to gain electrons? Okay, bigger masses. You're thinking on the right track. What else do you know about the elements that are to the over here in the right side? If we think about like the groups we talked about. The higher number means they have more valence electrons. Yes. So remember that octet rule? Our atoms are always trying to they want to have a full outer level. I full. So if they have more, it's going to be easier to fill up their valence electron level than if, like over here, sodium only has one valence electron. It's much easier to get chlorine. It's easier to give chlorine 1 and it to be full than to get sodium 7 to fill it up. Does that make sense? Go away. So there are less spaces to fill over here. All right at the top. Those valence electrons are closer to being full on the right side. All right, this bold line, I've highlighted it blue here, is the dividing line. So it kind of stair steps down, starting with boron and aluminum, and then stair stepping down. Everything to the left of that is a metal, except, of course, there's always somebody who messes it up. Hydrogen is not a metal. It's a gas. But it does live all the way on the left there, so that is the only exception here. So even though these things might not feel like a metal, like calcium, it's on the left-hand side, so we are calling it a metal. Sodium, salt. It's going to be considered a metal. Oxygen is not. Okay? So let's go through here. Is potassium metal or non-metal? You might need your periodic table, so you can see these. What do you say? It feels like it would be a non-metal. Where is it? Potassium is the K. So
I don't know. Yeah, it is.
it is a non-metal. Yours are weird. It's on.
It's on that. It's on the
Which-
non-metal side.
It is. Which side is it on?
Okay.
Which side is it on? Left or right?
Left.
It's on the metal side.
It's on the left side. It's on the metal side. So even though you feel like that, potassium is a metal. We are considering everything on the left
Oh, I
side.
was just looking at it.
Yeah.
It was pointing to hydrogen. And I thought
Yeah.
it was saying that
So
other
it's
side was
no, just hydrogen there. Everything below hydrogen is a metal. What about bromine? What is bromine's? I don't even know. BR?
non-metal.
BR over here. Whoops. Yeah, non-metal down here for bromine. All right, what about beryllium? What's beryllium's? Yeah. That's the Be here. It is a metal. Okay, where's helium? Yeah, number 2 up there, non-metal. All right, fluorine. This F will be a non-metal. Hydrogen. It's a tricky one. It's non-metal though. Silver. Yeah, it's they cut it out of our page on here, but it's down in this section. What's its symbol? A G. So it is a metal. And then nitrogen. Yeah, non-metal. So just be sure, even if you're like, that doesn't seem like a metal, check where it's at on your table. Their little memory device here. Iron is on the left side, and that's where the metals go. Okay? They also talk about semi-metals, or what do we call them? Transition metals. On either side of this stair step, so all of these that are touching, they have characteristics of metals and non-metals, because they're like just in the middle. So they call those metalloids or semi-metals. Your paper might also say transition metals, but that's what they mean.
The whole middle chunk from 3 to 12 is categorized as transition besides. These
Okay.
don't even have labels. I don't even know what those are.
Me neither. But the ones that are on the stair step are those semi-metals. Okay? Any questions about the metal, non-metal part? All right, the next section of this is where we're going to spend most of our time today. We've been talking a lot about electrons, specifically valence electrons. So a dot diagram or a Lewis dot diagram or a Lewis dot structure, anytime you see the dot, they are how you would draw an atom's valence electrons. So just the outer level. With our Bohr models, we drew every electron that it had. These dot diagrams are only going to show the valence electrons, just the outer level. But they're really helpful. You're going to use them a lot when we talk about molecular bonding. So for these, you start with the symbol of whatever element we're working with. So like here we've got neon, Ne. And then you put these electrons around the symbol in pairs, but we don't just go in a circle. They have a specific order that you fill them in. You always start on the top left. So number 1 is first. And then you go down to the right, left, back up, down to the right, left. So you like zigzag back and forth. Yeah, so you don't want to bunch them all together. And why would these electrons spread out? What do you know about electrons that would explain that? Yeah, they repel each other, so they're not going to bunch up. They want to be as spread out as possible. And that changes how they bond with other elements. So that's why we need to draw them in a specific order. We talked about, except for that first row, most of the ones we're going to work with have 8 available spaces for a valence electron. They want to fill their octet. So once you've got all 8 electrons on there, it's full. It doesn't have any openings. And then let's look at these. So lithium, where is lithium on the periodic table? Okay, second row, first column. You remember your electrons come from your group, which are your columns. So since lithium is in the first column, it's got 1 valence electron. So they started here, and that's the only dot we've got. Next, they showed what carbon looks like. So what row is carbon in? 14.
Well, 14 group, row 2.
14th group, we just use the last digit. So that'll be 4 valence electrons. And then you put them in order. 1, 2, 3, 4. Okay? Same idea for oxygen. What group is it in? Sixteenth group. So that's how it got the 6 valence electrons. And they would have gone in order 1, 2, 3, 4, and then back to the top 5, 6. And this says how many more before it's full? 2, they can always go up to 8. And it wants us to draw these for the following elements. So we've got beryllium. What's the symbol for beryllium? Be. Second group. So it's got 2. Where do they need to go? We always start on top. And then 1 on the bottom. You always need to go in that order. Top, bottom, right, left. Okay? Sodium is a trick. It actually starts with N. Nah. Na, first group. Nope. Nah, because that's what sodium sounds like. First group, so how many electrons? One valence electron. Where does it go? Top. Okay.
It's the 18th, but it's weird, so it's only 2.
Helium is weird.
The weirdo.
18th, but only 2 valence electrons. What is helium's symbol? He. Yes. Okay. So where did the dots need to go? Top and bottom.
Carbon is C and it's in the 14th row, so there's 4 electrons.
Carbon is just C. 14th. Wait, are they always in pairs? Okay, hold on.
But if it's supposed to be in pairs, like it's written on your paper, then what about
That they are
carbon
also.
and above? It's
That's right, those are all separated. It's fine. We'll come back to that later. So they did do carbon above. That's silly. Why did they put it down here? You already told me. This is the 14th group. So how many valence electrons? 4. Right. 1, 2, 3, 4. And then boron.
G, 13th row, 3 valence.
Okay, 13th group. 3 valence electrons. 1, 2, 3. Okay. It's fine. Questions about drawing dot diagrams? Okay, on the back of this page, we're also talking about ions. Okay, there. So, the number of protons tell you what?
Atomic number,
The atomic number tells you what?
how many protons?
And
And how many neutrons? Or is it electrons that's the same?
sometimes both. But the thing that's always the same is the element. So like, no matter what, if you've got 1 proton, that is hydrogen. No matter what else you have ever. We talked about was it just last week? With our scandium, if you change the number of neutrons, so like if I have 1 proton, but one of them has 2 neutrons and one of them has 0 neutrons, they're still hydrogen. But what are they going to be? Isotopes of each other. So today we're going to talk about if you change the number of electrons. So we're still going to be the same element, but this will be an ion. Electrons, when your number of protons are the same as your number of electrons, then your atom is just neutral because they cancel each other out. There's the same amount of positive as there is negative. But if you change the number of electrons, you're going to change the charge of your atom. So this says, why would you want to gain or lose electrons? We talked about that. Octet rule, your outer level wants to be as full as it can be. So if it can take electrons from something else, it will. They'll bond that way. But then it'll end up with a fuller outer shell. So we talked about earlier, metals lose electrons and they become positive ions or cations. So positive are cations. Nonmetals are more likely to gain, so then the negative ions are called anions. It's kind of like in math, positive and negative numbers. They gave us an example here with lithium. Lithium has 3 protons, 3 neutrons, and normally 3 electrons. So a positive 3 plus a negative 3, 0, they cancel each other out, and that's neutral. However, if lithium lost one of its electrons, we'd have a positive 3 and then a negative 2. And those wouldn't cancel out anymore. Yeah. 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 Right. Positives. If there are more protons, it's positive. If there are more electrons, it's negative. So this lithium ion has lost an electron, so now its net charge is positive. Yay. So, we talked about yesterday, or last unit, the protons and the neutrons made our mass. Now we're going to work with protons and electrons to find charge. Okay? Here's how they help to remember. Cations cough up electrons. They give them away. Those are metals. Anions accept electrons or gain them. Those are usually nonmetals. Okay, so what is the charge of an atom with 16 protons and 18 electrons? So 16 is going to be what sign? Positive 16. Our 18 will have what sign? Negative. So what is this charge going to be? Negative 2. All right. The next one we're getting more specific. So look at your periodic table. Where is oxygen? Row 16. Okay. How many protons does it have? Okay. Positive 8. If it's in row, we need to do a little extra math. It's in group 6. Said what? Row 2, group 16. All right, so we need to know if it's in row 2, that means its first row is full. How many are in that first row? 2, and then it's in the 16th group. So how many valence electrons does it have? 6. So 6 plus 2. Normally has 8, but it gains 2 electrons. So if it's got 2 more, how many electrons do we have? 10. So its overall charge, also -2. And then I made that way too hard. How many protons does beryllium have? Where is beryllium on the periodic table?
Row 2.
4. Okay, so its electrons should match its protons at the beginning, right? So row 2, group 2 should have 4 total electrons, but we're losing 2. So if we take away 2 electrons, how many is it going to have? Just 2. So we have 4 protons and 2 electrons. So this overall charge is a +2. Okay? Questions there? All right, so the last thing we need to talk about is how to show this. No, the ion notation. So you're going to still use your symbol for your element. So for here we've got Na for sodium, and then 1 positive. So it's got a positive charge and 1 electron lost. So over here, this box said, how many electrons does magnesium 2 positive have? So magnesium's proton number, if you go to its spot on the periodic table, it's 12. Minus its electrons. And we're kind of doing a backwards equation of what we have been doing. They're telling us the charge is a +2, so we can use that to figure out how many electrons it started with. So 12 minus the electrons should be a +2. I'll write this over here. What just happened? Okay, our 12 protons minus the electrons made a +2 charge. So to get that electrons by itself, what would we need to do? Like they showed it over there, but they show it weird. What's with the E? The 12. If it's 12, just +12, how do you move that? Yep. Do the opposite and subtract it. So your electrons, what is 2 minus 12? That would get us a -10. And then if these are both negative, yeah, they'd cancel each other out. Beep. So our electrons equal 10 electrons. It says you also could have found this by knowing magnesium has 12 protons and 12 protons and electrons if neutral. So a positive 2 charge would mean it lost 2 electrons. I don't really care how you find it, but both of those work. All right, and then we got a few questions down here. First one says, how many electrons does chlorine -1 have? So first of all, how many protons does chlorine have? 17. So if it's neutral, how many electrons would it have? 17. So if it was negative, remember the protons always stay the same. We would add 1 more electron, which would be 17 and 1 would just be 18 electrons. Kind of feels backwards, but our electrons are the negatives. So if we are negative, we need to add electrons. If we're positive, we need to subtract them. Everybody good there? The next one asks about nitrogen. How many protons does nitrogen have? 7. So if it's neutral, we need 7 electrons. But we want a -3 charge. So I'm always going to change electrons. If I subtract away electrons, yeah, we actually want to add electrons to be negative. Feels backwards. But yeah. So how many electrons are we really going to have? 10. Okay. Then we've got aluminum. 13. I think it's easiest to start, that gives you an easy starting point for your electrons without having to do the whole valence electron math. But now we have a +3 charge. So did we gain or lose electrons? Lose how many? 3. Which would be 10 electrons total. It does. It feels backwards because you want to change the protons to get positive, right? Except we can't change protons because then we change element. It does seem backwards.
Because if you gain, you're only add.
Right. Yeah. So since we are always just starting with the -1, it does feel backwards. Yeah, gaining electrons makes us more negative instead of positive. Okay?
So, the amount you subtracted, like, opposite sign of the tiny number?
Basically, yes, good. Good observation there.
I'm just confused because
That's where it's confusing.
Yeah, so you are always switching that sign. Whatever charge you have means you have the opposite. Like if it's positive, you lost electrons. So that's why we did minus when it was a positive. Yes. So make a little note. Positive charge means minus electrons. A negative charge means you added electrons. Any other questions about that part? All right, this bottom row says to give the ion notation. So what atom has 20 protons? Let's start there. 20. Okay, so the symbol for calcium is Ca. And then if it's only got 18 electrons, what's its charge going to be? So we've got 20 protons, 18 electrons. 2, positive or negative? No, you're right. Whoa. So you put the number first and then the charge behind it for this ion notation. Bless you. Okay. The next one, what atom has 6 protons? Carbon is just C by itself. So we've got 6 protons, 2 electrons. Yeah, a positive force, but we write it 4 positive. Good. And then the last one, 15 protons. Phosphorus. Just a P there. So 15 protons, 18 electrons. -3. So remember when you write it for the notation, 3 first, then the negative sign. Okay, what questions do you have? Good.